Okay, we're looking at number 15 on the review. We're looking at imaginary numbers. So remember that I is defined to be the square root of -1. So there's not actually a real number that we can square that would give us a -49. So what we do here is we split this up into the square root of -1 times the square root of 49. We know the square root of -1 is I. We know that the square root of 49 is 7, so that gives us an answer of 7i. So we might just want to think about this as anytime we have a negative under a square root, it is going to come out of the square root as an I. Part B isn't quite as pretty. I'm going to go ahead and put the negative with the numerator, so square root of -18 over square root of 25. So square root of 25 is pretty nice, that's just 5. So if we think about this as the square root of -1 times the square root of 18, square root of -1 is I. 18, remember, is 2 times 9, and 9 is 3 times 3. So we can take a 3 out. And we typically don't put the I in the front. Couple of ways you can write it. 3i square roots of 2 over 5, and that's totally fine. Or you can also write it as 3 square roots of 2 over 5 and pull the I kind of out to the end. So either one of those would be an acceptable answer. All right, now on 16 we're looking at operations. So the first operation we see is subtraction. What we have to remember to do here is to distribute that negative. So I get 10 minus I minus 12 minus 7i. And we want to put everything back in a plus bi form. So 10 minus 12 is -2. A negative I and a minus 7i make a minus 8i. So we would just leave our answer in this form. Now B is also a subtraction, but we need to do some rewriting first. We don't need to work with these negative square roots. So we're going to rewrite this as 2i times 3 minus. So I know the square root of 25 is 5, and then I know the negative comes out as an I. So I can rewrite that as 3 minus 5i. And then this one will be 1 plus 11i. Now, just like the last problem, I can go back and distribute that negative. And I can also distribute the 2i. So I'm going to get 6i minus 10i squared minus I minus 11i. Now we talked about I being the square root of -1. Remember the other part of that definition is if I square both sides, I get I squared equals -1. So right here where I have an I squared, I am going to replace that with a -1. So if I rewrite this, let me come over here, I get 6i. This is going to become -10 times -1, so it becomes a plus 10, minus 1 minus 11i. So 10 minus 1 gives me 9. Then when I put my i's together, I get a minus 5i. So this is the form we want to put our answer in. All right, so C, this one is a FOIL problem. So 4 times 3 is 12. My outside product will be 4i. My inside product will be -21i, and then I get -7i squared. So I'm going to replace I squared with -1. And I can go ahead and put these together if I want. So I get 12 minus, 17i. And then this becomes -7 times -1, so it becomes a positive 7. And that gives me 19 minus 17i. All right, so moving up to D, this one is also a FOIL problem, but before I FOIL, I need to rewrite this. This is 1 minus 2i. So remember, the square root of 4 is 2, the negative comes out as an I. And this becomes 3 plus 6i. So we don't want to try to multiply these negative square roots. We do get into some problems there. So you always want to do the i's first. So now when I FOIL, I get 3 plus 6i minus 6i minus 12i squared. So we got a couple of things going on here. Our negative terms, our middle terms canceled, and then our I squared becomes a negative 1. So that's going to give me 3 plus negative 12 times negative 1 is a positive 12. So in this case, my i's dropped out, and I just ended up with a whole number answer of 15. All right, now for E, I'm dividing complex numbers. So I really don't divide at all. What I'm going to do is I'm going to multiply by the conjugate. So remember, the conjugate for a complex number is you just change the sign in the middle. So I'm going to multiply the top and the bottom by 5 plus I. And I think it's easier to think of this negative right here as being up here with the 3. So if I multiply that, that's going to be negative 3 times 5 plus I. I'll do that in a minute. And here I'm going to FOIL. So I get 25 plus 5i minus 5i minus I squared. All right, so I don't have a whole lot of room here. I'm going to write really, really small. So if I distribute the negative 3, that's negative 15 minus 3i. On the bottom, those middle terms cancel, and I get minus I squared, but remember that's minus a negative 1. So I end up with 25 minus negative 1, which gives me 26. Now this isn't a bad way to leave your answer, but if you go back to the a plus bi form, it has you split it into negative 15 over 26 minus 3 over 26i. Now the nice thing about splitting it is you can reduce each fraction separately, and so you're more likely to reduce your fraction. All right, so f is the same idea, but I do need to rewrite this first. This is going to be 2 minus 3i over 3 minus I. All right, so I need to multiply by the conjugate on the bottom. I'm trying to get rid of the i's on the bottom. So I'm going to have to FOIL the top and FOIL the bottom. So for the top, I'm going to get 6 plus 2i minus 9i minus 3i squared. On the bottom, I get 9 plus 3i minus 3i minus I squared. All right, so everywhere I had an I squared, I'm going to put a negative 1. So the top becomes 6 minus 7i, if I put my similar terms together. And this is going to become, I don't really have a place to put it. This becomes a negative 1 right here and right here. So that's going to be negative 3 times negative 1, which is going to give me a positive 3. On the bottom, the middle terms cancel, and I get 9 minus a negative 1. Okay, so once again, replacing that I squared with a negative 1. So I get a 10 on the bottom, and a 9 minus 7i on the top. Again, I'm going to split that, 9 over 10 minus 7 over 10i. All right, now the last thing we have with complex numbers are powers of I. So I'm going to come out here to the side, and just remember that we know I to the first is just I. We know that I squared is negative 1. So remember that I cubed is I squared times I. That's negative 1 times I, so that's negative I. And then I to the fourth is I squared times I squared. That's negative 1 times negative 1, which is 1. So when you're raising I to powers, these are the only 4 answers you can get. So they're going to cycle through. So I to the 5th would come back up here. I to the 6th would be the same as this one. I to the 7th would be the same as this one, and so on. So what we can do is if we have a number, like here we have I to the 25th, I want to see how many times it's going to cycle through that. So since there's 4 numbers there, I'm going to divide by 4. It's going to go through 6 times with a remainder of 1. So that means it's going to go through this list 6 times, but then for the remainder of 1, it's going to land up here at the top. So that means my answer is going to be I. Now for the next one, let me take all that out. If I divide it by 4, I get 52. That's going to go once. This is going to go perfectly, which means it's going to cycle through 13 times and it's going to stop at the bottom part. So notice this is remainder 1, remainder 2, remainder 3, and I can't have a remainder 4 when I'm dividing by 4, so that'd be remainder 0. All right, so I'm going to land on that last spot, and that tells me that that's going to be a 1. So the trick is to memorize these first 4. If you know these, then you can just sort of count how many times it goes through the list and see where it will land.